back some properties that we've talked about, okay? One property was log base b of b. Do you remember what this equals? Or think about it, like b to what power gives me b? Yeah, to the first. Good. Okay, so there's another one, Aiden, that you're probably remembering. Log, what was it? Log base b of 1 equals b to any, or b to what power gives me 1?
0.
Good, that one's 0. And then log base b of b to the x, what did that all equal? Do you guys remember? Very similar to this one.
This is the stuff I couldn't hear. I was like, I have no idea how to do this on the test.
You couldn't hear any of it?
Well, I was kind of.
Oh, you're fine, you're fine.
I'm sorry. I was
No.
just like,
Well, I'm pretty sure I was using a green marker that day. You couldn't see a single thing with that stupid green marker. Yeah. What happens here? So think about when you're up at this one, this exponent is 1, and the whole thing equals 1. So if we have log base b of b to the x power, the whole thing just equals x. You're close though, Lane. Essentially, our log base b and b is canceling.
Could you do like an example that with like numbers?
Yeah,
Like,
we
see
will.
how it
Yep.
works?
So we're gonna do all those today. We're just doing a quick review of these properties so we kind of remember what some of them were.
Okay.
The last one was b to the log base b of x. So what happened there? B to the log base b. B log base b cancel, that whole thing equals x. Okay, so these are 4 properties that we've talked about that we kind of need to bring back in. So like we saw them, we used them a little bit, we put them in some number context, like we tried to implement them, and then I was like, but they'll come back in 4.6. So here's 4.6, they're back. Hello, Quinn, what's up? Where you been?
Back.
Came from that way, that's okay. So we're gonna do
Downstairs.
some examples here. We're gonna start off with some easier ones. I'd say the tough thing about this section is that when we're doing some of these examples, they end up being like you have to manipulate things maybe in different ways than you ever have before. So let's do the first example. 8 to the x equals 2 to the x plus 2. Okay, and I'm gonna ask you to solve for x with these. So if you've noticed in your notes, up until this point, we've always been doing expressions. So exponential expressions and log expressions. When we bring in the equal sign is when this becomes an equation, right? Like equal sign, equation, like those two things go hand in hand. So we've simplified as far as possible with most of these, but we were never getting like a definitive answer. Without an equal sign, you can't get a definitive answer. With an equal sign now, we can. So think about maybe, oh, one other property I wanted to show you. I forgot, we're gonna bring some new ones in. So let me show you, b to the y equals b to the x. So here's another property. Think about all the 4 properties we've already learned. We're gonna bring a couple new ones in. When we have the same bases with different exponents, they could be the same exponent, but they're generally going to be different exponents. What happens here is our base b's cancel each other out, and our exponents can just be set equal to one another. Okay, so we use these, but that just means that they're the same number. So in this case, I'm directly showing you this property because I want to show it to you in this example. Do I have the same bases though?
No.
No, I don't. Could I make it the same bases by manipulating things a little bit? In other words, yeah, we can, but the question is how. So think about if I wanted to write this as a 2, because am I ever going to make 2 into 8? Like, is that going to happen? No, not going to happen. Yeah. Which one?
No, it's going in the back then.
Okay, well, the sun's coming from this direction, so it's usually one. So think about what number can we have two to, oh, guess we need some lights. Yeah,
I was like, now I can't see it at all.
I didn't notice my lights were off, it was so sunny. So 2 to what power can give me 8? Essentially. 3, yeah, 2 to the third power. So we are rewriting 8 as 2 to the third. So 8 was taken to the x power though. Right? So are these two things equivalent? 8 to the x and 2 to the third to the x. Are those two things still equivalent? Yeah, because 2 to the third is just 8. So now this is set equal to 2 to the x plus 2.
When did we just switch to,
2 to the 3x, right?
yeah, but no, the one is two,
I think I'm confused what you're asking. Sorry, go ahead. Say it in a different way.
two squared up.
This one? This one?
And then why did wouldn't that be? two squared?
Oh,
How
so
are they
because
equal?
Because 2 squared plus 2 to the x is not the same thing as taking 2 to the x plus 2. So one other thing, exponents to exponents. What happens there? Exponent to exponent. What operation? Yeah, good guys, multiplication. So this is 2 to the 3 times x, which is 3x, equals 2 to the x plus 2. Are we now in a position that we can apply this property?
Yeah.
You betcha. What's gonna happen? Tell me. Good. And I get 3x equals x plus 2. And am I now in a position that I can solve this? If you pass algebra 1, you sure can. What's my first step? I can subtract 2. What else can I do? Yeah, if I subtracted 2, I would have a little bit longer path to solve for x. So I'm gonna go with the shorter path and subtract x to give me 2x equals 2. Now my path, good. So you get x equals 1. If you didn't believe this, if you're like, I don't think so. I don't think that's right. Couldn't you go back and check it? Let's try. I'm not going to make you do this for every single one of them, but could you not go back and check this? That process would be called substitution, right? So we are going to take 8 to the x equals 2 to the x plus 2. So what value did I get for x? 1. So I'm now going to substitute 1 in for x. So this would be 8 to the 1 equals 2 to the 1 plus 2. 8 to the first equals 2 to the third. We know 2 cubed is 8. So 8 equals 8, which means checking this confirmed x does in fact equal 1. Again, will I make you do this every single time? No. Is it nice to know that you can always check your answer if you're a little like, wasn't always super confident in it? Hopefully. Questions on this one? Questions at all? You guys have a hand raised? Or is that just you like? Okay, I want to try another one with you. This one has kind of a two-part setup. Same property that I want to try to force you to use, but more of a two-part setup. Okay, we're basically showing you how you can manipulate numbers to make this into what you want. So again, I want you to solve, and this is, yeah, that'll work. 4 to the x equals 1/2 to the x minus 3. So before we get started on this problem, I want to remind you of something. Whoops, Ashley. I want to remind you of something we've done just very recently with exponent properties. If I have 1/3, so 1/3, and I ask you, is there a way that I can bring this 3 up so that it's 3 to some exponent? Is that something I can do? Can I bring something from my denominator up to my numerator? Yeah, I can. What has to happen to my exponent though? Yes, it has to be the same and it has to be negative. So it currently was 1, right? So it still has to remain 1, but we have to make it a negative version of that exponent. Okay, so this is very similar to if we had x and it's in the negative first, and we were like, well, we don't want negative exponents, figure that out, solve that. It would have become 1/x to the positive 1, right? We can move numbers from the denominator to the numerator and the numerator to the denominator. You just have to alter the exponent. So how will that apply here? I can erase this now, but how does that apply to the problem that we're currently working on? Think about that 1/2. Does 4 and 1/2 currently match? Okay, oh, ours? Yeah. I was like, Caitlin. Sorry, go ahead, Jenica. There we go. Yes. Okay, so Jenica's already saying like, we definitely have nowhere near matching right now. So I'm not gonna make 4 into a fraction, but I can make 1/2 into a whole number. So she said, well, what about I could take 1/2 and change it to 2, because I can bring this 2 up as long as I make my exponent negative. Right, so that needs to be a 2 to the negative first. This is still taken to the x minus 3. Okay, so now let's rewrite this. 4 to the x equals 2. -1 to the x minus 3. You just need to distribute that -1 to each of those. So -1 times x, -x, -1 times -3, +3. Right, exponents to exponents, you multiply those exponents. When we have 2 of them, you need to make sure that you distribute it. Okay, so now do I match? Like, did I do the thing I needed to do? Do I have the same bases? Oh, I still don't. Then what do I do next? Can I divide by 2? There we go. We want to alter our number. So I'm going to manipulate this 4 because that can be 2 to the power of 2, all to the x. Still equal to the -x plus 3. One last step. Okay, 2 to the 2x, because we need to multiply your exponents together, equals 2 to the x plus -x plus 3. Your 2's drop away. Right, 2's are dropping away. Let me keep solving this over here. That leaves me with my exponent of 2x set equal to my exponent of -x plus 3. Okay, what do I do next? When I'm trying to solve this, think back to algebra 1. What are you gonna do? Yeah, add x. That's my first easiest step. To give me 3x equals 3. Yeah, divide by 3. X equals 1. Could I go back through and check this? Absolutely. Am I going to right now? No. No, well, that was super. I was like going through it and I was like, dang, we're gonna have x equals 1 again. It will not always equal 1. Good question. Super coincidence. Questions on any of that? It's kind of a long process, right? Like, there's kind of a lot of things that's going into that right now to make us be able to get an answer of X. So it's the second that we bring in an exponential function or a log function, our process of solving becomes a lot longer. It's not just solving for X, but it's first, how do we get X out of the exponent? Or how do we get X away from the log to then be able to solve for it? Okay. So I want to do one more with you, and I think I want you guys to try this one on your own. And I fully think that this one is at your guys' speed, that you'll be able to do this one. So I again want you to solve. This time it is 9 to the 2x equals 27 to the x minus 1. Okay, so I want you to still apply that same property of getting the same bases to your exponents and try to solve this one. You're more than welcome to talk to somebody about this.
Yeah.
Okay. Is the 9 to 27 ratio the thing that we can't get?
Yeah.
Okay,
Is that everything divided by 3?
we can't divide it by 3. We have to think about 9, like 9 to what power or 27 to what power will give us the other number. So is there a way that you can have 9 to some power that gives you 27? Is there, sorry, is there a power in which you can take 9 to some exponent and get 27? Is good, okay. So let's go down another level then. Do they have any same multiples? Kyle's got it, okay. 3 to what power gives us 9? Good. 3 to what power gives us 27? So 3 times 3 is 9, times 3 is, good, so 3 to the, good, there you go. 3 to the second, 3 to the third. Now you guys can finish it off.
Those two don't cancel out because they're in the same block.
But I need to have the same exponent. We need to have the same base.
Oh.
For clarification.
So we just multiply the twos together.
Yeah, good, good. And then make sure you distribute that through to everything. So I think what's gonna happen is we're gonna continue 4.6 tomorrow. 4.6 worksheet Friday.
Is there a lot more of this we have to learn?
No, there's not. There's only like 2 other kinds of examples we have to learn. I wanna make sure we take time for them. Okay, 30 more seconds. 30 more seconds. I wanna make sure you try this one because there's like 2 different pitfalls you might take. I wanna make sure that you don't take those easy mistakes.
My changes from like 50 after cheaper.
Oh.
I never did that to the other. What? They had to get other ones.
They did have two numbers one day.
I got
That was
it.
awesome.
I bought them.
That was awesome. Yeah, I do like their turkey.
I like the
wraps.
pretzel boxes.
Yeah, those are good. Yes, yeah.
Or the excellent, like.
Yeah.
Oh.
Yeah. Yeah.
Well, fine.
Okay, so let's go over this one. So as a class, we determined that there was no number in which, like, there was no exponents that you could take 9 to some exponent to get 27. You also couldn't take 27 to some exponent to get 9. So at that point, you kind of had to like hit the drawing board again and say like, okay, well, what multiples do both 9 and 27 have? That multiple was 3. So then we figured out, well, 3 squared is 9 and 3 to the third is 27. So that same equal base is going to be 3. Now we have 3 to the second to the 2x. So we need to multiply 2 and 2x to get 3 to the 4x. Except on the second side, many people forget to do this part. This is technically a quantity, right? So when we take 3 to the third to the x minus 1, 3 is multiplied by the quantity of x minus 1. So it's 3 to the 3x minus 3. Same bases. Cha-ching. Cancel out those 3's. You now have 4x equals 3x minus 3.
Why can't you take out the bases when they're in the parentheses?
Because we have 3 squared and 3 cubed. They're not exactly the same number because their exponents aren't the same. So we have to distribute that exponent first. That's a great question. Okay, so subtract 3x to get x equals negative 3. How many of you, with this little hint in the beginning, got that one? Nice. That's okay. Nice. That's good. That's good. Nice job, guys. Okay. We.
I totally did not.
That's what I was.
Yeah,
Right?
I do.
I managed to get to a number though. That actually equals 1/3.
I don't want to start a new kind of thing. So we're going to go ahead and stop it there.